All right, good morning everybody. We're out in the woods behind my house again, and today we're going to go over just some of the basics of setting up a fixed area plot to estimate forest density and things like basal area. And we're going to do a few examples, just some really basic stuff of laying out the plot, and then using a diameter tape to begin getting diameter measurements on some of the trees. So you can refer to the PowerPoint slides on plot sampling that I've posted on Play-Doh to get a sense of what we're doing as well and what the plots look like. We're going to use fixed area circular plots, and we're going to sample large trees, things over an inch in diameter, in a 1/20th of an acre plot, and we're going to mark out the boundary of that. And then we're going to sample trees that are less than an inch in diameter but over a foot tall in a 1/1000th of an acre plot, and we're going to mark radius on that too. And so this is the data sheet that you would be using normally, and we'll work on filling that out in a minute. But for the big plot, it has a 26.4 foot radius, or 8 meters, depending on which measurement scale you're using. So we're going to lay that out. I'm going to just a tape here that I'm going to run out to. I'm going to assume that my plot center is this little beech sapling right here. Normally it would be just a point in the ground, but I'm going to mark it using this beech sapling. I'm just poke this into the ground right here, and then I'm going to run my tape out 26.4 feet. And normally I would do this in, there's 20, 21. Normally I would do this in 4 or 5 directions, depending, 3 to 5, depending on the visibility, how easy it is to see around the plot. And I'd simply mark my plot boundary with a flag or a piece of flagging like this, so I know which trees are in the plot and which trees are not in the plot. And I'm only going to do this here. You get the point though. I would do this, I would run the tape out in a couple of directions and set some flags so I know what my plot boundaries are and which trees I'm going to count and which trees I'm not going to count. For our purposes, you don't need to watch me run 4 or 5 different tape lines. So then I'll refer again to the data sheet, and I'm going to be Team McDonald, so I'm just going to fill out the data sheet. Today is the 24th of November. Plot number 1. Aspect refers to which direction does the slope face. So if I'm standing with my back to the direction the slope of the terrain is, what direction then am I facing? And this one is basically a southeast facing slope. I could measure it with my compass to get an even more accurate reading, and you might do that if you were doing this in the field. But for me, I'm just going to say southeast face. So the sun is rising right now in that southeasterly quarter. Prism basal area is something that we won't cover in this class. If I had my GPS, I would write my GPS coordinates down on the data sheet as well. And you would be wanting to do this if you were doing this in a real data collection situation. Now, for measuring trees, I've got, in this 1/20th of an acre plot, I've got a big table here. And the way we usually work this is in the first row, I would have the species. And you can write whatever code you want for the dominant species. Mine, the dominant species here is going to be American beech. So I'm just going to write beech in the first cell of this first column. And then as I encounter other species, I will write them in the other cells in this first row. And then what I'm going to do is write the diameter of each beech. So that gives me a count. You know, every diameter represents one tree, and it also gives me the diameter measurement. And so you'll see how this works. We have a tape, a diameter tape, which corrects for the formula for figuring out diameter of a circle. So instead of measuring the circumference and then having to figure out what the diameter is, the tape has a regular measuring side, right? This is just in inches. This side is measuring diameter in inches. So this side has already been corrected for estimating diameter based on the circumference. So this is the side we're going to use. And if you refer to the slideshow, one of the key measurements in forest inventory is something called diameter at breast height. And breast height is always 4.5 feet above the ground. It's not, you know, based on your height or anything like that. It's always a measurement of 4.5 feet off the ground, or I think it's about 1.3 meters off the ground. And so I already know basically where breast height is on me, so I've done this a lot. I wrap the tape around, and it has a nice hook, so if you're on a larger tree, you can just hook in. I'm gonna hook it in here, run the tape around, and then I'm measuring. Here's the 0 line, and I'm measuring breast height off of this 0 line. So it's 9.3 inches on this American beech. So then I would write that down. Beech, 9.3. And so for every tree that is over 1 inch in diameter, I'm going to write down that diameter measurement. Here's another beech. Now, when you encounter odd stems like this, where there's a branch scar and some other knobbiness, you try to work around that. So I don't try to measure diameter at that point. I would measure a little bit above or a little bit below. Here again, there's our 0 point. So this would be slightly below 4.9 inches. So I'd call this 4.8. Go back to my data sheet. Beech, 4.8, and so on. So here, if there are a lot of trees in your plot, sometimes it can get a little bit tricky to remember which ones you've measured already as you're working your way around and which ones you haven't. I sometimes by convention, you can kind of scuff the leaves at the base of a tree to note that you've already visited that one and taken the diameter. We'll go do another one, this one, so you can see our flag. Here's a red maple, and here I can just reach around with my tape, and this one would be red maple 6.3. And so I'd go around to all the live stems